First up, we have Altech Batteries. Altech is a specialty battery technology company with a JV agreement with world-leading Germany Battery Institute IKTS to commercialise the revolutionary CERENERGY sodium chloride solid-state battery. Presenting for the company today is Martin Stein, who is the CFO and Company Secretary. Martin, thank you for your time. Over to you.
So what's the future of grid storage batteries? That's what my presentation is at the moment. Now, before I talk about, the future of grid storage batteries, I want to cover lithium-ion batteries. Now, lithium-ion batteries have a plastic separator sheet and a liquid electrolyte. Both of those are organic materials and is what's in those flammable materials with a ceramic solid-state electrolyte, and that will eliminate the fires and explosions. We can see here a Tesla vehicle that has caught on fire. There's thermal runaway, which is where the temperature gets so high, it catches on fire and those organic materials burn, and they burn for a long time because there's oxygen produced at the cathode level. We also know that lithium-ion batteries are restricted in their temperature range because of the viscosity issues with the lithium. If they operate outside of 15 degrees or to 35 degrees, the lithium becomes viscous and the charging capacity decreases substantially. So lithium-ion batteries are not well suited in very cold climates, and they're not well suited in very hot climates either. And we know lithium-ion batteries, just like your mobile phones, have a very limited life of about 7 to 8 years, and they degrade very quickly. So their life is limited. And we also know with lithium-ion batteries that, of course, they're at the mercy of the global supply chain of critical raw materials, such as graphite. 90% of the world's graphite is sourced from China. This poses a geopolitical and a sovereign risk, and China has recently come out and said that they intend to limit the export sales of graphite, putting more pressure on the lithium-ion battery industry. Lithium-ion batteries also use a lot of cobalt, with 70% of the world's cobalt coming from the Democratic Republic of Congo. This has child and ethical labor issues in sourcing cobalt for the lithium-ion batteries. And of course, copper. A lot of experts saying that there simply isn't enough copper to support the world's renewable energy transition. And lithium-ion battery, electric vehicles, I should say, use 2.5 times the amount of copper than an internal combustion engine vehicle. So, is there a technology for batteries that is completely fire and explosion proof, that has a large operating temperature range and can last for more than 15 years and doesn't use any lithium, copper, cobalt, graphite, or manganese? Well, there is. This is called Altech's CERENERGY sodium chloride solid-state battery that has a solid-state electrolyte, can't catch on fire, and uses sodium chloride, which is common table salt. It's readily available, and sodium chloride is about $30 US per ton. It's very cheap. This technology was developed by Altech's joint venture partner in Germany, Fraunhofer IKTS. So, because this battery doesn't have the viscosity of the lithium, we can take this into any temperature range in the world. It's been tested in temperatures from -40 to 60 degrees. It works perfectly fine. So this battery has the potential to be a global product. It also doesn't use the lithium, copper, cobalt, graphite, or manganese, so we don't have those critical raw material supply chain issues. And I think when you're talking about countries and governments securing their energy needs, they don't want to rely on all those other countries for those raw materials. If they can source the raw materials internally, which they can with sodium chloride, there's a lot of benefit to having an energy storage system where the raw materials can be sourced internally. So let's look at how the technology works. Now, what we do is we take that solid ceramic electrolyte that that gentleman's holding, we put sodium chloride or salt plus recycled nickel powder inside that terminal, inside that tube, that electrolyte. That all sits inside a negative stainless steel canister, and that's the negative part of the battery. That is a 250 watt cell, which is the equivalent of a residential solar panel in capacity. Now, when we charge the battery, this is where the technology that was developed by Fraunhofer really kicks in, because what happens is the chloride ions from the sodium chloride stick to the nickel. The sodium migrates through the ceramic electrolyte. That's the key to the technology. And it forms a sodium molten, a metal, liquid metal sodium anode between the ceramic electrolyte and the stainless steel canister. That's the charging of the battery. When it discharges, the sodium molten goes back the other way through the ceramic electrolyte. It clings back onto the nickel ions. It forms, the nickel ions release the chloride ions. The sodium chloride happens again, and the process starts all over. This is a table that shows how we compare towards other popular battery technologies. Now, we're very competitive, if not better, on a lot of those attributes. The top line is the density. We're a little bit heavier than lithium-ion batteries, about 20% heavier, which is not such an issue for stationary batteries, which we're looking at, but we're a lot lighter than redox flow, and we know there's a market for that. Maintenance cost down the bottom is very important. We don't have any moving parts or fans, so we're very cheap for maintenance over the life of the battery. Now, this table here shows you where we sit compared to other technologies in terms of power and energy. You can see there that we're right in the middle, so we provide a burst of power and a burst of energy, which is required for what we're trying to do, which is grid storage batteries, and that is the good technology for this solution that we're trying to provide. Now, this is where grid storage batteries come in. This is the future of the renewable energy transition. This shows a typical renewable energy grid with renewable energy powers in the form of solar and wind, putting power into the grid. But what's happening around the world is that the grids can't support it, and it's not being used as much as it can be produced. So that surplus is literally being pumped into the ground. Germany pumped $2 billion US into the ground in renewable energy that was wasted last year. This problem with intermittent renewable energy power happens when there's wind cover, and also at nighttime when the sun doesn't shine. And also EVs coming online are putting more pressure onto the grids. So the future of renewable energy transition is to put massive sea container sized batteries onto the grid. This will store the surplus of the renewable energy when it's in excess, such as daylight hours, store it in the batteries, and then return it to the grid when it's required. This is the future of the renewable energy transition. We simply cannot have a transition to net zero without having batteries to stabilize the grids. As I mentioned before, Altech's joint venture partner is Fraunhofer IKTS in Germany. Fraunhofer is the German Government Research and Development Institute. They're highly credible and highly reputable, and we're delighted to have them as the joint venture partner. They have done all of the R&D work on this technology, people. So this isn't an R&D project. This is now taking the R&D technology that's been proven and scaling it up to a commercial 120 megawatt hour plant. Fraunhofer has a 35 million euro pilot plant in Germany where they've developed the technology. This is what we're looking at. They've also spent 25 million euros on the costs to develop the technology, and they have it now ready to commercialize. They got 5 and 10 kilowatt hour battery modules completed, fabricated, working, tested. It's all working fine and now ready to commercialize. So how is Altech and Fraunhofer doing this commercialization? Well, Altech owns 8 hectares of land in the state of Saxony in Germany. This is where the proposed plant is envisaged to be constructed. The plant will be all renewable energy, and the CERENERGY battery is 100% recyclable, and that can be done on our premises with the recycling facilities on the premises. This battery meets all of the ESG requirements and is a completely green product. What we're seeing in this vision is a 60 kilowatt hour battery pack. Now, this battery pack contains 240 of those 250 watt cells, 48 cells in each rack, 5 racks stacked high to create 60 kilowatt hour of battery capacity in a completely insulated pack. Altech then takes 18 of those 60 kilowatt hour battery packs and we put them into a standard 20-foot sea container. That creates 1 megawatt hour of power, or for people doing the maths, it's just over 1 megawatt. 18 times 60 is 1.08, so it's just over 1 megawatt hour of power. These are pre-assembled at our premises. We transport them to the customer's site. We can stack them up to 3 high because we don't have the safety and the fire issues with lithium. And within 5 minutes of arrival, it's a very simple plug and play design. The customer can have 1 megawatt hour of battery capacity put onto their grid. So we've recently released the bankable feasibility study with the economics for the project. Now we've got a revenue of 109 million euros per annum. We also have a net present value of 169 million euros. And we have an EBITDA of 51 million euros per annum. So on the first 120 megawatt scale plant, we have an economic project. The strategy is to go to gigawatts, and we will become more economical to produce at that level. But on the 120 megawatt hour plant, we have pleasing economics. The board's decided to move forward with the financing of the project. We have selected all of our key suppliers in Germany, which are some of the world's leading robotics, engineering, and manufacturing companies. We think we've assembled a very good team of suppliers to make this project a success. And now we're moving forward with the financing to construct the plant. We can see here some more of Fraunhofer's equipment in their pilot plant facility. We can see there the high purity alumina being mixed to create the ceramic electrolyte. We can also see here some of the salt, the sodium chloride, some of the sintering of the cells at 1600 degrees to remove all the moisture. And there's just a little bit of quality work being looked at the cell. The cell being put into a stainless steel shimmy. The shimmy then being put into the stainless steel canister, which is the negative terminal for the battery. That's a 250 watt cell. Some nickel powder, recycled nickel powder being measured out. There's some welding being done of the tops of the cells. There's Dennis, one of our project leaders in Germany, doing the welding. Some thermal testing being done at Fraunhofer. Fraunhofer's team of 30,000 scientists and engineers are still heavily involved in this commercialization. So we still have access to all of their staff and their equipment and facilities. We can see here the 60 kilowatt hour battery prototype that's been completed. This battery prototype has exceeded our expectations. It's working better than we could have ever expected. So now with the financing of the project, we've appointed the global corporate advisory firm KPMG. They're based in Frankfurt. We've appointed them as our advisors to the financing process. We've got applications in for grants and subsidies with the European Investment Bank, who are very supportive of green projects in Europe and in Germany. We've also spoken to BNP Paribas in France, as well as ING Bank in the Netherlands. They've expressed interest in being the lead bank for the financing, and we're looking to get the offtake for the 120 megawatts. We've signed our first offtake agreement letter of intent about 6 weeks ago with a German company. We're speaking with data centers in Europe, and we're also speaking to utility providers in Germany that are making the transition to the renewable energy. We're hoping to sign up the rest of the offtake, get the finance, and get the first scale 120 megawatt hour plant constructed and the batteries being produced. We are listed on the ASX under the code ATC, and we invite you all to be part of the new grid storage future as part of the renewable energy transition. Thank you very much.
Thanks for your presentation, Martin. It was a great presentation. Love all the visual videos and everything. Thanks for that. So I do have a few questions.
Pleasure, Abby.
I do have a few questions for you. So does Altech have any interest in high purity alumina?
Well, it does, because we have some kaolin assets in Western Australia. Kaolin is the raw material that makes the high purity alumina. It's a very interesting question, actually, because if it wasn't for the high purity alumina interest, it wouldn't have led into the joint venture with Fraunhofer. Fraunhofer uses high purity alumina as the material for the ceramic electrolyte. So it's quite a long story, and I won't go into it, Abby, but it was the link with high purity alumina that led to this CERENERGY battery project being part of Altech. And we're very fortunate that we've got this joint venture with Fraunhofer, who are very, very credible and reputable.
And you're focusing on grid storage, but what about other battery markets, for instance, the electric vehicle market or small consumer devices like cameras and smartphones?
No, we're not looking at those products because the electric vehicle market is a lithium battery dominated market. They require a very light technology. Obviously, weight is an important factor when you're talking about vehicles. So we're not targeting that market. We're targeting the grid storage battery market, which is the future of the renewable energy transition. In fact, Tesla announced its quarterly results last week, where the battery segment of their business has gone ahead in leaps and bounds. Elon Musk said it is growing like wildfire, and Tesla saying that the future of their business is grid storage, is going to be more grid storage battery dominated than it is electric vehicles. So we know the grid storage battery market is growing at 28% compound annual growth rate. It's a huge and lucrative market. For the first time ever, recently, the state of California put the biggest amount of power into its grid one evening from grid storage batteries. It put 6 gigawatt hour of battery capacity into its grid, which surpassed nuclear, gas, all other forms of traditional energy. So we know grid storage batteries are the future, and we think we're at the right time and the right place.
And in terms of the batteries themselves, are you in an R&D phase, or is it now all about scaling up and commercializing?
Very much the latter. We're in this commercializing. So we know the R&D works. We know these batteries work. We're now commercializing this, trying to produce the batteries and produce sales revenue. And then without looking too far forward, I guess, we have the worldwide rights to manufacture, license, and distribute this technology globally.
And then about the cost of sodium chloride batteries, will they be cheaper than lithium ion equivalents?
We think so. And in the battery industry, there's a metric that's called the levelized cost of storage, Abby. Now, the levelized cost of storage incorporates all of the costs of having the battery. Now, that includes things like obviously the upfront costs, but the cost also includes ongoing maintenance costs. It also includes the benefit to customers of how many times they can charge and discharge the battery. Obviously, the more they can charge and discharge it, and the longer it lasts for, the more valuable that battery is. So when Altech looks at the levelized cost of storage of the battery compared to lithium-ion technology, it's about half the cost over the life of the battery. So a lot cheaper to run and operate these batteries in the long run than lithium-ion batteries. And safer, they don't catch on fire, they don't explode, and they don't use all of those raw materials.
And then, so more on Fraunhofer IKTS. Who are they and what role do they play in the project?
Well, I mean, we go over to Germany every 2 months as part of the project development. Now, I've seen Fraunhofer with my own eyes, and um, I try and communicate that to potential investors, but Fraunhofer is the world leading German government R&D institute. They've got 30,000 employees throughout Germany. They have 76 institutes. I guess you can imagine being German government, their credibility and reputation is of the utmost importance. They will only go out with a product when they're very, very confident with it. People are aware of the MP3 media player. The MP3 media player is in your mobile phones. It was a movement towards music technology. Now, Fraunhofer developed that technology themselves. They joint ventured that out with Sony in Japan, and the MP3 player is one of their biggest successes. But they have a number of credible technologies that they've brought to market, and we're optimistic that the CERENERGY battery can be another one.
And at what stage is the battery plant?
So the definitive feasibility study has been completed, the design has been completed, all of the key suppliers have been selected. We have designed all of the product specifications. So we have permitting in place. We have the land and we have the first offtake. So the remaining pieces of the puzzle are to get the remaining offtake, which we're working hard on, and to tie this into the debt, equity, grant, and subsidy finance to construct this plant.
And what sorts of customers will you concentrate on for your batteries, and what sort of market opportunity are we talking?
So in the first instance, we're looking at utility providers that are transitioning from fossil fuel power to renewable energy. And as you saw in the presentation, they can't make the transition without having the batteries to store the surplus of renewable energy to stabilize the grids for when the energy is required. So we think utility providers are a key potential customer, and also data centers that are moving away from dangerous lithium-ion batteries to more safer technologies. We're also looking at them. But I think if you look at the future of the renewable energy transition, you're going to see batteries in almost every application. You're going to be seeing them on mine sites that are running renewable energy. You're going to be seeing them as part of military bases, as part of schools, as part of hospitals. So the market, I think, is almost endless. But in the first instance, we'll be looking at the low-hanging fruit in the form of the utility providers and data centers.
And are there any other companies developing sodium chloride batteries? And if so, where do you see Altech differentiating there?
Yeah, really good question. So there is a company out of Switzerland that produces smaller size batteries more for the residential requirements. And I will suggest to your listeners that if they hear sodium ion batteries, which we're seeing a lot of discussed at the moment, sodium ion batteries are not the same technology as what we're using. Sodium ion batteries still use copper, cobalt, graphite, or manganese. And manganese, they can still catch on fire. They merely replace the lithium with sodium. So that technology, whilst it uses sodium, it's nothing like what we're doing. So we're quite unique in looking to produce these 1 megawatt hour batteries for industrial requirements.
And what are the next steps and key milestones investors should keep an eye out for over the year ahead?
Well, the big targets are to get the rest of the offtake and to get the finance to construct the plant. And if we can get that, I think it'll be a very different company than what it is now. So they are the very, very big objectives that Altech is looking at achieving strategically. We're also fabricating a second 60 kilowatt hour battery prototype as well. So those three things are key drivers of Altech's strategy.
Thank you so much for your time and your presentation, Martin. We'll be keeping a close eye on the company and we'd love to have you on the webinar in the new year.
It's been a pleasure, Abby. Thanks for having me, and Merry Christmas to you and your listeners, which is not very far away now. So
No, Merry Christmas to you too. Have a great weekend, Martin. Thank you.
thank you very much.